All right, everybody, welcome to Math with Grace. Today we're going to be working through Math 7, Book 701, Lessons 8 through 15. We're going to be starting today on page 29 and working through these fractions, and then the pre-test for that, or like homework, if you're just using it as homework, is here on page 28. All right, so let's get started. We're doing fraction multiplication. It says multiplying fractions and mixed numbers with canceling. To multiply more than two fractions at once, we multiply all the numerators together and all the denominators together. You can cancel any denominator with any numerator. You may even be able to cancel the same number more than once. Change any whole number or mixed numbers to improper fractions before canceling and multiplying. So we'll go over, this gets a little messy. I'm not going to say it doesn't. So we'll go over changing mixed numbers to improper fractions in a moment. But let's go ahead and start with some of these canceling, right? And what is really beneficial is to cancel beforehand, before you multiply, because then we get rid of all the extra stuff. If we just multiply straight off the bat and then need to come back and cancel, then we have to try to figure out, well, what is cancelable, right? And so to skip that, if we cancel right off the bat, then there shouldn't be anything left to reduce. Our fraction should be at its lowest value. So I'm looking here at 3/4 times 8/9 times 2/9. All right, now we can cancel any denominator with any numerator. I just like to start on the left and work my way to the right. Can I cancel this 3 with anything? Well, yes, 3 and 9 have the factor of 3 in common. And there is 1 3 in 3. And there are 3 3s in 9. Okay? Now, next, does 4 have a factor in common with 8? Yes, it does, right? It has a 4 in common. There's 1 4 in 4, and there are 2 4s in 8. Now, when it starts getting messy, kind of like this one is over here, this one's not too bad. But if it started to get messy, I like to circle what I have left behind so far. Okay, in this fraction we haven't even touched. I'm not going to circle the ones because 1 times anything is just the anything. So this is just being a 1 is kind of something we can ignore for right now. Now, do 2 and 9 have a factor in common? They don't, right? Does 3 and 2 have a factor in common? They do not. Okay, we cannot cancel this 2 and this 2 across like that. We can only cancel a denominator with a numerator. Just like we can't cancel this 3 and 9 because they're both under the line. They can't cancel with each other. Okay? So now we multiply. And here's what we're multiplying. 2 over 3 times 2 over 9. All right? To multiply this, we multiply the numerators, the tops. 2 times 2 is 4. And we multiply the bottoms, the denominator. 3 times 9 is 27. So the answer is 4/27. This is. All right? Okay. Part B. We have 3/4 times 4/5 times 4/9. All right? Does my 3 have a factor in common with 5? No. Does my 3 have a factor in common with 9? Yes, just like in the last one we did, right? There's 1 3 in 3, and there are 3 3s in 9. Okay? This 4, does it have a factor in common with 4? Of course, right? They are their own factor. So there's 1 4 in this 4, and there's 1 4 in that 4. Now I keep moving forward, right? I've already canceled all of these, so what about this 5? Does this 5 and this 4 have a factor in common? No, it does not. Okay, so what am I left with? This 5, this 4, and this 3. All the rest are 1s, and so they aren't that vital. Okay, so multiplying across, 1 times 1, again, is 1. 1 times 4, right, is 4. 5 times 3 is 15. So we have 4/15. All right, let's look at part C. 2/3 times 3/5 times 1/4 times 5/9. All right, starting at the left. 2, does it have a factor in common with 5? No, it does not. Does 2 and 4 have a factor in common? Do they? No, they do. They do, right? They have a 2. So there is 1, 2, and 2, and there are 2 2s and 4. Down here at this 3, does this 3 have this factor in common with 3? Yes, it does. 1 3 in 3 and 1 3 in this 3. Okay. How about 5? Does 5 have a factor in common with 1? While they both have the factor of 1 in common, that doesn't actually help us reduce, right? So we'll skip that part. What about this 5 and this 5? Again, they're the same number, so they can both be made a 1. Because it's kind of like writing 5 over 5, right? 5 over 5 is equal to 1. So we can change them both to 1. Any number over itself is equal to 1. All right, I'm going to start circling these because we're running low, because this is just a 1. This is just a 1. This is a 1. It's how it started. Here's a 1. So I don't have anything to pair up with this 9. So all across the numerator, we only have 1s. So my numerator is just a 1. In the denominator, I have 2 times 9, which is 18. So 1/18. All right, let's look at line 2. For line 2, we have 7/16 times 8/9 times 10/11. All right. Starting here with the 7, does the 7, well, really, and you can compare it to its own denominator, right? But 7 does not have a factor in common with 16. 7 is a prime number, so it has to be a multiple of 7 for it to work. Just the same, it doesn't work with 9 or 11. Okay, so 7 cannot be canceled with any of the denominators. 16, well, 16 and 8 have a factor in common, right? And that factor is 8. And there's 1 8 in 16 and 8, and there are 2 8s in 16. Now, before I leave this 2, because it can still be usually canceled with something else, at least sometimes, right? Weren't able to cancel it here, but I have another even number over here. So 2 and 10 have a factor in common, and this is what it meant by being able to cancel the same number more than once, right? Because 2 and 10 have the factor of 2 in common. And 2, there's 1 2 in 2, and there are 5 2s in 10. Okay? Then we can look at our 9. We already decided 9 and 7 didn't have a factor in common. Do 9 and 5 have a factor in common? They do not. And what about our 11? It does not have any factors in common. So we're left with this 9, this 11, and a 5. All the rest are 1s. Okay? Oh, nope. Oh, we almost forgot it. That's why I circle things. So we have that 7. All right. So in the numerator, I have 7 times 5. And 7 times 5 is 35. In the denominator, I have 9 times 11. And 9 times 11 is 99. So 35/99 is the simplest form of this fraction already. We don't even have to try to factor it any farther because we've factored all of this as much as we could. Okay? Take a look at part B for number 2. 5/12 times 3/5 times 6/7. Okay? Starting at my 5, I have a 5 over a 5, and we already talked, right? Any number over itself is 1. So I can change both of these to 1. 12 and 3 have a factor in common, and 12 and 6 have a factor in common. So you have to decide which one do you want to cancel with. I'm going to go ahead and just cancel with the 3, and then I'm going to cancel probably another time with the 6. Either way you do it. Well, I guess if we use the 6 first, we wouldn't have to cancel twice. But I'm going to go ahead and do it with the 3 anyway. So there is 1 3 in 3, and there are 4 3s in 12. Okay? because this is an even number, 4, I look for another even number in the numerator, and that's this 6. And they have the factor of 2 in common. There are 2 2's in 4, and there are 3 2's in 6. I'm going to circle these. And then down here with my 7, I really don't have anything else to cancel with because I have 1's, 1's, and a 3, and 7 and 3 do not have a factor in common. So I have now factored everything. In the numerator, I have a 1, and a 3, so the answer is just 3. In the denominator, I have a 2, a 1, and a 7, so 2 times 7 is 14. Okay, let's look at part C. 7/15 times 3/8 times 5/14. Right, starting with my 7. It does not have a factor in common with 8, but it does have a factor in common with 14, right? There's 1 7 in 7. There are 2 7's in 14. Okay, what about this 15 down here? Well, there is a factor in common with 15 and 3, and that's a 3. So there's 1 3 in 3, and there are 5 3's in 15. Now, because 5 is a slightly larger number, we want to double check. Can I cancel it anywhere else? And I can right here, right? Because I have a 5 over a 5. 5 over 5 means I can change both of these to 1's. And then I'm left, I'm going to circle my 2 before I lose it. I'm left with this 8, okay? But all I have in the numerator at this point are 1's. So there's nothing left for me to reduce my 8 with. Remember, I cannot reduce this 8 with this 2 because they're both on the bottom of the line. They're both in the denominator. So across my numerators, I have all 1's. So it's just a 1. In the denominator, I have 8 times 2, which is 16. Okay. All right. Now we're into the mixed numbers. And first thing we have to do is change them to improper fractions. This is how we change a mixed number to an improper fraction. Okay. You're going to look at this first one, 2 2/3. The 3, you're going to multiply by 2. You're going to multiply the denominator by the whole number. So 3 times 2 is 6. Sometimes I like to just go like this. 3 times 2 is 6, okay? 6 plus 2 is 8. So this as an improper fraction is going to be 8/3, okay? And the denominator that's here is what's going to be in the denominator here, okay? So 10 times 2 is 20. 20 plus 1 is 21 over 10, okay? Remember, it has to have a denominator, otherwise it's no longer a fraction at all, right? We're just changing it from a mixed fraction or mixed number to an improper fraction, which means the top number is bigger than the bottom. The numerator is larger than the denominator, okay? So 12 times 2 is 24, plus 1 is 25/12. Okay, now we can start reducing and finish by multiplying. So I'm going to start with my 8, right? 8 and 10 have a factor in common, and that factor is 2. There are 4 2's in 8, and there are 5 2's in 10. Now 4 is still a pretty large number, and it's an even. I mean, we're either going to get an even or an odd, right? It's a pretty good number, so let's keep looking. It doesn't factor any more with the 5, but it does factor with this 12, right? They have a factor in common, that factor being 4. There is 1 4 in 4, and there are 3 4's in 12. Okay, 3 times 4 is 12. Coming down here to this 3, now I'm looking up in my numerator, right? Do 3 and 21 have a factor in common? They do, right? They have the factor of 3. There is 1 3 in 3, and there are 7 3's in 21. Okay? Now, 7 and 3 don't have any factors in common. But what about this 5? 5 and 25 have a factor in common, right? Circle those two. There's 1 5 and 5, and there are 5 5s and 25. And so now we've gotten all the way to the end, and there's nothing more to factor. So in our numerator, we have 7 times 5, which is 35. And in our denominator, we have just a 3 times 1 times 1. Remember, we don't need to worry about, well, 1 times 1 is 1, 1 times 3, okay? Now, when you're doing these improper mixed number, improper fraction ones, 9 times out of 10, you're going to be left with an improper fraction, okay? And so then we need to change it back to a mixed number, okay? So 35 thirds. How do we get it back to a mixed number? Well, how many 3's are in 35, right? That's what we need to think about. How many 3's are in 3, right? Well, there's 1 3 in 3. How many 3's are in 5? There's 1 3 in 5, but this had leftovers, right? It had 2 left over out of 3, okay? So 3 goes into 35, and if you prefer like actually setting it up like a long division problem, then go ahead and do that, right? 3 goes into 3 one time, 3 goes into 5 one time, and there's 2 left, okay? This remainder of 2 goes in the top of your fraction, and the denominator is going to stay as a 3. So the answer is 11 and 2 thirds. Okay, let's do the next one. We have 1 and 3/8 times 3 and 3/4 times 2 and 2 thirds. So 1 and 3/8. 1 times 8 is 8, plus 3 is 11. So I have 11/8 times 4 times 3 is 12, plus 3 is 15/4. 3 times 2 is 6, plus 2 is 8 thirds. Okay? I gotta kind of split these up so I don't run into anybody else's space. All right. Now we can start 11/8 times 15/4 times 8 thirds. So 11, does it have a factor in common with any of these? No, because it's too big, right? What about this 8? Well, here I have an 8 and an 8, and 8 over 8 is 1, so both of these can be changed to 1. Does this 15 have a factor in common with this 3? It does, right? It has a 3 in common. So there's 1 3 in 3, and there are 5 3's in 15, sorry. What about this 4? This 4 has nothing left to factor with, because it doesn't have factors in common with the 11 or the 5. So we factored everything. Now we need to multiply. In our numerator, we have an 11 and a 5. So 11 times 5 is 55. In the denominator, other than 1s, all we have left is a 4. So that becomes our denominator. All right, again, improper fraction, we need to change it back to a mixed number. So how many 4's are in 55? Well, there's 1 4 in the first 5, okay? And there was a remainder of 1 because 5 minus 4 is 1. So I like to just put the remainder of 1 here. If you want to do it this way, because you're more confident in that, then go ahead and do that. I'm going to do it kind of like the sneaky way a little bit. So how many 4's are there in 15? Well, that's 3 4's, right, is 12. 15 minus 12 tells me I have a remainder of, I don't know why I started writing it too, 3/4, okay? 15 minus 12 is 3. We put the 3 over the denominator of 4. So 13 and 3/4. Okay? A way to think about this is we're trying to break things into groups of 4, right? There's 13 whole groups of 4 inside of 55. And then we're left with 3 parts of 4, right? Not quite enough to make a whole group of 4, but 3 parts of 4. That's how you can think of these fractions. All right, part C. 3/16 times 3 3/7 times 7/8. So 3 times 6 is 18, plus 1 is 19/6. 7 times 3 is 21, plus 3 is 24/7. And then this one just gets to stay the same because it's not an improper fraction, okay? Now, starting with my 19, it's a pretty big number. I don't expect there to be anything in common over here. 7 doesn't go into 19 evenly. 8 doesn't go into 19 evenly. So we can't reduce that 19 at all. What about, I mean, it's a prime number, so we're kind of stuck, right? What about the 6? 6 and 24 have a factor in common, and that factor is actually a 6, right? There's 1 6 and 6, and there are 4 6s in 24. All right, so then let's look at the 4. 4 and 8 have a factor in common, and that factor is 4. And there's 1 4 in 4, and 2 4s in 8. And last, we have 7 over 7. Any number over itself is just a 1. I'm going to circle this 2 down here. And so we're left with, in the numerator, 19, 1, and 1. So that is 19. And in the denominator, I have 1 times 1 times 2. So it's just a 2. All right, so 19 2s is what we have here, or 19 halves. And so we need to change this back to an improper fraction. So how many 2s are in 19? Well, there are 9 2s in 19, right? Which is 18. So then I have 1 left over out of 2. So the answer is 9 and 1 halves, okay? All right, the last row. We have 5/8 times 2 2/7 times 7. All right, 7 is just a whole number, but we still need to fix the 2/7. So I have 5/8 times 7 times 2 is 14, plus 2 is 16/7 times, now we need to change this whole number to an improper fraction as well. And how we change a whole number to an improper fraction is we set it over 1, because 7 over 1 is just 7. Any number over the number 1 is just whatever's in the numerator, okay? So that's how we make this whole number into an improper fraction. All right, so let's begin. 5 we have in our numerator here, but it does not have any factors in common with any of the denominators. So what about this 8? Does it have factors in common with the numerators? And it does, this 16, right? There's 1 8 in 8, and there are 2 8s in 16. So my 5 I couldn't factor, here's a 2. Again, I have a 7 over a 7, and 7 over 7 is 1. And then I'm done. And I happen to have all 1s in the denominator, and I have a 5 times 2 in the numerator. So in the numerator, 5 times 2 is 10. Since there are all 1s in the denominator, technically we have a denominator of 1, but this is still an improper fraction. So to make this a proper number, we just write 10, okay? Because I remember how I said, any number over a 1 is just the number. So the answer is just 10. Part B, we got 2 left to do, and then you can work these fractions here on page 28 on your own. But let's do these last 2 together. I want to make sure everybody is getting through these okay. All right? So we have 2 3/5 times 4 1/2 times 1 2/3. So 5 times 2 is 10, plus 3 is 13/5. 2 times 4 is 8, plus 1 is 9 halves, or 9 over 2. 1 times 3 is 3 plus 2 is 5/3. Okay? All right, let's take a look. 13 is a big number, but it's also a prime number, so I don't expect it to go into anything, and it doesn't. 5, though, I have 5 over 5, and we know a number over itself is just a 1. What about this 9? Well, 9 and 3 have a factor in common. That factor is 3. So there's 1 3 in 3, and there are 3 3s in 9. 2 can't factor with anything in the numerator, and so we are done with our factoring. 13 times 3 in our numerator is 39 over just a 2, right? So now we need to see how many 2's are in 39. Well, there's 1 2 in 3, right? But there's one remainder from that because 3 minus 2 is 1. Then how many 2's are in 19? Well, just like we did over here, right? There are 9 2's in 19. And that left, again, a remainder of 1 because it's 19 minus 18 is 1. And we put that over our 2. So 19 and 1/2. All right, last one. 3 3/7 times 7/8 times 1 3/4. Okay, 7 times 3 is 21, plus 3 is 24/7 times 7/8. That doesn't change because it is a proper fraction already. And then I have 4 times 1, which is 4, plus 3, and that is 7/4. All right, so let's begin. Again, 24 is a big number, but 24 and 8 actually have a factor in common, and that factor is 8. So there are 3 8's in 24, and 1 8 and 8, okay? This 3 does not factor with a 7, a 1, or a 4, so I'm going to circle it. Here, I have 7 over 7, and we know a number over itself is just a 1. So those are gone. And then I'm over here, and I'm left with this 7/4. And this 7/4 doesn't factor with anything because all that's left is the 3. Okay? So, in my numerator, I have 3 times 7, which is 21. And in the denominator, I just have a 4. So here's our improper fraction. Now we need to switch it over to a mixed number. So how many 4's are in 21? Well, there's no 4's in 2, right? But 5 4's make a 20. And 21 minus 20 is a 1. And we put that over the 4. So this is 5 1/4. Again, if you are more comfortable setting it up as a division problem and working it out, please do that. But you're getting, this is book 7, you'll be moving on to book 8 next time. It will be good practice if you can work through kind of doing a little bit of that without having to write it all down. And I'm not saying you should, but I'm saying it's good practice to start trying that. As you get further into algebra and stuff, it will make life a little bit easier. Okay? All right. So this is our work with multiplying fractions and mixed numbers with canceling. Okay? You're going to work on these problems here on page 28 on your own, and then meet me back here for the next practice set. As we turn to page 31 for our next practice set, you'll notice that the unit test is in between. It's always right in the center of the book. A responsible person, adult, probably best, or if you have a folder set up for your math class, you could remove this if it's in your way. I just fold them in half, but the test will be taken, for those of you working through this at home, the test will be taken at the end of the book, okay? So don't lose it, as it's kind of important. All right, so I just fold them in half so they're out of my way. But they can fairly easily, since they're right in the center of the book, they can fairly easily be removed and set aside for later. Now, we're going to be working on page 31 here, and the practice problems for those are back on the other side of the test, back on page 30, okay? But we are doing percent applications. So looking at this, we are going to be finding the percent of a number. And to do that, it says to find the percent of a number, we change the percent to a decimal and then multiply. So what we want to work on when we're looking at applications 9 times out of 10 in math mean a story problem. Okay? And even though this is not quite a full sentence, right, it is still a story problem, technically, because it's got words telling us what to do, right? In math, the word of means to multiply, okay? The word of is the same as multiplying. So this reads 25% of 20, so it means 25% times 20, okay? Now, to change a decimal into a percentage, we are going to, our decimal technically is right here, right now, right? We are going to move that decimal place 2 places to the left, okay? So it's going to go boop, boop. Basically, we're dividing it by 100. So our percentage, or our decimal is 0.25 times 20. I don't usually like to put the X because as you move further forward in math, really into the next book, and maybe some at the later part of these books, we will actually use variables, and X is a very common variable. And so I usually will use parentheses to show multiplication. Okay. Sometimes the book uses a dot to show multiplication, and the dot would be written like this, 0.25 times 20, okay? So it's kind of a big dot floating in the middle. That's also multiplication. I typically use parentheses. So just so we understand each other, that is what's happening here. Now, they did the long multiplication, right, of this problem. And so they found that the answer is 5. I will be doing my multiplication slightly differently, but that's okay, right? We'll get it to work out just fine. All right. Calculator 2, honestly, would be fine. If your parent is okay with that. I'm okay with that. But let's look at these problems. Find each number. It says 40% of 60. So how do we write 40% as a decimal? Well, we're going to take 40 and divide it by 100, or move the decimal 2 places. So it's 0.40 times 60. Okay? To set that up, how I would set this up in a long multiplication problem, I would be putting the decimal at the top and writing it like this. Okay? So my 0 is going to come down because that's how zeros are. 6 times 4 is 24. If I could get my numbers to write in the correct order, 24. Okay. 6 times 0 is 0, plus 2 is 2, right? And then blah, blah, blah. That's the rest. We need 2 decimal places, so my decimal would fall right there. So the answer is 2.4. Okay. Looking at part B, we have 145% of 40. Now, my decimal is here. To divide it by 100 or move the point 2 places, right? We only want 2 places, so don't let it confuse you because it's 100 and something percent. So my decimal is 1.45 times 40. And since the reason I set this one up this way is because this number ends in a 0. And so to me, it's just easier to set the problem up that way because we know the 0 is going to fall down. Now, would I always set the decimal before the other number? No. But because this one ends in a 0, let's not do more work than we need to, right? Constantly multiplying by 0, it wasn't really necessary over here, right? If we had set this one up as 0.25 times 20, 2 times 5 is 10, carry the 1. 2 times 2 is 4 plus 1 is 5, and then put our 2 decimals and we're done, right? We did it. And so just because this one ends in a 0 makes it easier to set it up this way. And remember, math only builds, right? We're constantly going to be building and adding more steps and more steps and more steps. So anywhere that you can cut your steps down a little is going to benefit you in the long run, as long as you're doing it correctly, of course. All right, so my 0 just falls down. 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. 4 times 1 is 4, plus 1 is 5, right? Remember, we need 2 decimals, so our answer is 58. All right? Okay. This next section, it says computing sales tax. And now, as you can see, if you've been using these curriculum for a while, and you want to go back and have like a really big lesson review, you could check out these 2 books. But computing sales tax, this is you can find the total cost, including sales tax, by first multiplying to find the sales tax, then adding to find the total bill. However, a quicker way, especially when using a calculator, is to mentally add the tax percent to 100, then multiply to get the answer. What do they mean? Let's take a look here. Find the total cost. Well, it's $8.95 with a 7% sales tax. If they want the total cost, they mean the original price plus the tax. All right? Now, to find the original price, that is the 1 that they're talking about. They say multiply it by 100%. Let's just look at it like this. How would I write 7% as a decimal? Well, my decimal is here, right? I'm going to move it 2 places. Now, there isn't a number in front of the 7, so we're going to stick a 0 in there. So 7% as a decimal is 0.07, okay? Now, to find the final cost, instead of it being 0.07, we are going to use 1.07. This 1 represents all of the $8.95, okay? And then the 07 is the tax. So, times $8.95, okay, equals what? So, we grab our handy-dandy calculators, which I can never remember how this one does. It's got its own special on button. Try to get that so you can see it, okay? And we have 1.07 times 8.95. Okay? 1.07 times 8.95 equals 9.5765. Now we're going to write the whole thing out, even though we're talking about money here, right? And do we usually have this many decimals when we're talking about money? No, we have 2 decimal places. So we're rounding this 7 based on a 6. Rounding this 7 based on a 6. And so it's going to bump it up, right? So the total cost is going to be $9.58, right? The 6 bumps that 7 up to an 8. So the total cost is $9.58. That is the cost of the item plus the tax. Okay? All right, let's turn the page. All right, here at the top of page 32, we have $16.50 with a 6% sales tax. Okay, how do we write 6% as a decimal? Again, 2 spots. There's an empty space, so we're going to fill it with a 0. Okay? Then we're going to add a 1 to this. So it's going to be 1.06 times $16.50. Okay? So $16.50 times 1.06 equals $17.49. This time, we don't have to write it out or round it because it's already just 2 decimal places. Okay. The next one, $7.79 with a 4% sales tax. Okay, let's write our 4% as a decimal, 0.04. Then we're going to add a 1 to that, so 1.04 times 7.79. Okay, 7.79 times 1.04 is $8. Well, it's 8, 10, 16, right? So 8.1016. So we're rounding a 0 based on a 1. Is it going to change it at all? No, because that 1 is too small to change. So the price is going to be $8.10. Okay. Last one. $5 with a 7% sales tax. So changing our percentage to a decimal, 0.07, adding 1 to that, 1.07, and then multiplying that times $5. Okay, so 5 times 1.07 equals $5.35. Okay, easy peasy. You know, the page before this was like, oh, you could do it this way, multiply the tax and then add it back, or easier way is to set up your decimal, add a 1 to it. It said multiply it by 100%, but that's the same thing here as adding a 1, and then multiply. Okay, so we're going to do it the easier way, the one-step way. Okay, 2 steps is too many. Let's not make things harder than they need to be, right? Okay, last section here. Sorry, I got things in my way. All right, my last section down here. Finding discounts and sale prices. So again, working with our percentages. It says discounts and sale prices are both figured the same way. Mentally subtract the percent of the discount or sale price from 100%, then multiply this percent by the original price. What does that mean? Let's take a look. If the original price of an item is $12.97, but it was on sale for 15% off, we figure the sale price as shown, right? Here's how I want you to think about it. This box here, this is how we will be thinking about it. Okay? If we're not paying for 15% because it's 15% off, then we are paying for 85%, because remember, a percentage is always 100. It's always 100. And so if we don't have to pay 15% of the 100, then we have 85% left over that we do have to pay. And to write 85% as a decimal is 0.85, right? 100% of the item is $12.97, but we only have to pay for 85% of that item, okay? And we're going to be using our calculator here to work through these, okay? All right, let's take a look at problem number 6. The regular price was $18.65. The sale price is 25% off. If you're not paying 25%, okay, what are you paying? Well, you're paying 75%, okay? How do I write 75% as a decimal? Well, I'm going to move my decimal over 2 places, and it's going to be 0.75. So I'm going to take $18.65 times 0.75 to figure out what my price is going to be, what my end price is going to be, right? So $18.65 times 0.075 equals, and it equals, oh, I put too many, put the 0, I messed up typing it in. So let's try that again. 18.65 times 0.75, not 0.075, 0.75 equals, and it's 13.9875. Okay, so we're rounding this 8, because remember, we're talking about money. We need 2 decimal places. We're rounding this 8 based on a 7, And the 7 is big enough, it's going to push that 8 up to a 9. So the price is $13.99. All right. Let's look here. The regular price was $48.50. The sale price is 20% off. If we're not paying for 20%, we are paying for 80%. Okay? To make 80% a decimal, we move the decimal 2 places, and it's 0.80. So I have $48.50 times 0.80. And what does that equal? Well, let me see if I can get it on screen here. All at once, I don't think I can. If I scooch down a little. Okay. So I have $48.50 times 0.80 equals, and the answer is 38.8. Now, we're talking about money still, right? And so is 0.8 a proper way to write change? No, we need 2 decimal spaces. But the fraction or the decimal ended, so we're just going to add a 0 at the end. So it's going to be $38.80. Okay? Do not add the 0 before the 8, you add it to the end. All right, taking a look at number 7. Find the cost after the discount. Okay, a discount and a sale is the same thing. Don't let the verbiage confuse you, right? The cost was $70 before an 8% discount. If you're not paying 8%, okay, you are paying 92%. To write that as a decimal, we move our decimal over 2 places, and it's 0.92. So $70 times 0.92 is equal to what? Okay, grabbing our calculator again. We have 70 times 0.92 equals 64.4. Now, that's not how we write dollars, right? So it's going to be $64.40. All right, last one. The cost was $32.50 before a 4% discount. So if we are not paying 4%, we are paying 96%. 96 as a decimal is 0.96. Okay? So now we need to multiply that out. We have $32.50 times 0.96. What is that going to equal? So $32.50 times 0.96, oops, 6 equals 31.2. Again, that is not the proper way to write dollars, so we're going to add a 0 to the end and make it $31.20. Okay? So that is the lesson for percentages. Okay, the practice problems are back here on page 30. So go ahead and work on those on your own, and then meet me back here for the next practice set. All right, the next practice set begins on page 34, and it is called Expressions and Equations. The first part of this is expressions using multiplication and division symbols. It says here, a number and variable written together show multiplication. So this is why I don't like to use the x for multiplying, because is this 4xn or is this 4 times n, right? It gets a little confusing. So 4 directly next to a letter is multiplication, okay? The dot shows multiplication. The parentheses show multiplication, and the x is typically probably what you're used to seeing, but if you look over here, this x does not mean multiplication. This x is literally an x. So we won't be using this x to show multiplication. We will be using one of these 3 methods, where either the number and the letter stand right next to each other, there's a dot in between, or we use parentheses, okay? A fraction bar means that a number or variable on top is divided by the number or variable on the bottom. okay? If you think about a fraction, or sorry, a division bar, there's a line with a dot on both sides, right? The dot on both sides represents a number or a letter, right? So n divided by 7, or n over 7, is the same thing. 7 over n means 7 divided by n. Always the top, the numerator, then the denominator when we're dividing, all right? So in these examples, 8 was substituted for n, okay? In these examples, 8 was substituted for n. So 12 times n, since n equals 8, we can, since they're equal to each other, we can trade anywhere we see an n for an 8. So they changed this n to an 8 and then got their answer. They changed this n to an 8 and got their answer, and same here. They changed this n to an 8 and got their answer. So that's what we're going to be doing in this first section here. Substitute 12 for n. N equals 12. So anytime we see an n, we can write 12. So 10 times 12. Remember, when you're multiplying any number times 10, we just boop this 0 to the end. So that's 120. In part B, we have n over 6, or 12 divided by 6. And 12 divided by 6 is 2. Here we have 72 divided by 12. Okay. How many 12s are in 72? Well, there are 6. Okay. So the answer is 6. And here we have 8 times 12. And so if we set this up, we have 8 times 2, which is 16. 8 times 1, which is 8, plus 1, which is 9. So the answer is 96. All right? Okay. Over here at the top of page 35. Simplify each expression. Okay? When we're talking about our order of operations, remember we have, please excuse my dear Aunt Sally, where this is parentheses, this is exponents, or radicals, but that's for further along in math. This is multiplying, this is dividing, adding and subtracting. Right now, the multiplying and dividing and the adding and subtracting can be done in any order, but we always start at the top and work our way down, right? So, please is parentheses, and so that's what we have here to deal with, right? So what is 12 minus 8? That has to be done first. Well, 12 minus 8 is 4, right? 12 plus 8 is 20. And now we have 4 times 20, which is 80. Okay, 4 times 2 is 8, 4 times 0 is 0. All right. Here, again, we're starting with our parentheses first, and we have 6 plus 8, which is 14, times 5. I'm not a fan of this 5 not being in its own set of parentheses or being at the end, but we got to work with what we got, right? So 14 times 5, okay? 5 times 4 is 20. 5 times 1 is 5, plus 2 is 70. All right, here we have 12 times 12. Well, 12 times 12 is 144. And then here we have 5 times 16. If we want to set this up at the long multiplication problem, we have 5 times 6, which is 30. 5 times 5, or 5 times 1, sorry, is 5. 5 plus 3 is 8. So 80 is our answer. All right, the next section here is called simplifying by combining like terms. Okay. The variables n, 6n, and 2n, and they're talking about in this, and the numbers 8 and 4 are the terms of the expression. Okay. The terms are separated by a plus or minus sign. That's how we know one term from the other. To simplify an expression like this, we first combine the terms that contain a variable, then combine the terms that do not have a variable. Here's what we need to remember, and the book doesn't state it. the sign that is out front of a term, this one doesn't have a sign, so it's implied that it's positive, right? But this sign that is out in front of a term belongs to that term. See how they've circled it with the term? They've circled this negative belongs to that 2n, okay? We have to remember that. Now, circling everything and drawing all these arrows can get a little confusing. So here's how we are going to do it, okay? I am going to start on the left and work my way to the right, and I'm going to set a specific symbol for each type of term. So our first term here is a variable, and I'm going to underline it. And then what I'm going to do is I'm going to underline every other similar variable, every other like term to an 7x. And that's going to be this negative x and this positive 3x. And you can see that I'm underlining the sign that belongs to it, okay? Then usually for my constants, remember a constant is just a number. It's always the same thing. I like to circle those. Now, you could set up your coding however you want, but this is typically how I would do this type of problem. So we end up with 7x minus x plus 3x and 6 plus 2. Those are the two parts of this problem, okay? Now, when we're adding like variables, basically we just want to add the coefficients. So this is going to be 7 minus 1, even though we don't write a 1 here, there's like an invisible 1. 7 minus 1 plus 3. So 7 minus 1 is 6 plus 3. 6 plus 3 is 9. So we have 9 x's. Okay? 6 plus 2 is 8. So our answer is 9x plus 8. Okay? Let's take a look at part B. We have 2n. I'm going to underline the 2n, and then I'm going to underline every n after that, right? And here's a 5n. And then I have a positive 3, a positive 4, and a negative 2. Now, I'm not going to write it out this time, but if writing it out like this helped you, then go ahead and do it that way. But here I have basically 2 n's plus 5 n's. If I have 2 n's, 2 cards with the letter n written on it, and you have 5 cards with the letter n written on it, together we have 7 n cards, right? We add up all our cards. We have 7 cards with n's on them, so we have 7n. 3 plus 4 is 7. 7 minus 2 is 5. And there's our answer. Okay, here is a y and a 3y, and then I have a positive 7 and a negative 4. Again, I have 1 y, and you have 3 y's. Together, we have 4 y's. All right? 7 minus 4 is 3. And there we go. We did it. Okay? So however you want to mark your terms is totally fine, as long as, like here the book shows they're circled everything and then drew arrows. It's kind of confusing. If you mark each term differently, so our x terms are marked differently than our constants, then you know I'm going to add up all the things that are underlined, and I'm going to add the things that are circled. Okay? Okay, continuing. This part says dividing to solve equations. It says an equation that includes a number multiplied by a variable can be solved by dividing both sides of the equation by that number. And their example here is 3n equals 12. N wants to be by itself, okay? The variable always wants to be by itself. It doesn't like other people in its swamp, okay? It is being multiplied by 3 in this case. So to get rid of the 3, we need to do the opposite of multiplication, which is divide. And so that's what they did here. They divided both sides by 3. Now 3 over 3 is 1, so we can just cross them out. They cancel. That leaves the n by itself. And then 12 divided by 3 is 4. Okay, so our variable doesn't like people. It wants to be all alone, by itself, nobody else around. Okay, so that's our goal as we work through this. Okay, all right. Looking at problem 4 is done for you. Part A and B, let's take a look at part C. 5 times n equals 60. N wants to be by itself. It's being multiplied by 5. We are going to do the opposite and divide. Okay, both sides. If you don't do both sides, then you've changed the equation. It's no longer means the same thing. My 5's cancel, so n is now by itself. 60 divided by 5 is 12. Now, part D and part B over here is the check. See this check box? They want you to check your work. They want to know, is 5 times 12 equal to 60? And it is. Okay? Looking at problem 5A. 9n equals 27. N wants to be by itself. It's being multiplied by 9, so we are going to do the opposite and divide on both sides. N is equal to 27 divided by 9, or 3. So then the question is 9 times 3 equal to 27? And it is. All right, last one. 4 times n is equal to 28. N is being multiplied by 4, so we're going to do the opposite and divide. N is equal to 28 divided by 4, which is 7. So is 4 times 7 equal to 28? Yes, it is. Okay, that's how they want you to do these check ones. It's always good to check your work. All right, let's turn the page. We are at the top of page 36, and it says solving two-step equations with division. It says here that some equations must be solved in 2 steps. And then it says study these examples. We're going to look at this example. It has the equation 3x plus 12 equals 27. Now on the last page, we said, right, that x wants to be by itself. The variable always wants to be by itself. And so we would get rid of this 3 by dividing, right? But before we can do that, we actually need to get rid of what I call the outliers. And that's all of the things not touching the x, but they're on the same side of the equal sign. And in that case, it's this 12. This 12 is in my swamp. I want you to get out of my swamp. So what do we have to do? Well, the 12 here is a positive 12. So we're going to do the opposite of adding, and we're going to subtract that for both sides. Okay, that cancels out here because 12 minus 12 is 0. So now the 3x is by itself. And now that this term is the only term on this side of the equal sign, we can do the division that we need to do to get to our answer. Okay, so let's take a look at these. 6n minus 32 equals 16. This n we eventually want to get by itself, but right now it's got this outlier in its swamp. It's being subtracted, so we are going to do the opposite and add to both sides. Okay, negative 32 plus 32 is 0. So now our 6n is all by itself on that side of the equal sign, which is exactly what we want. 16 plus 32 is 48. Okay, now 6 is being multiplied by n. We're going to do the opposite and divide so that n is equal to 8. Okay, and then they want you to check it. I'm going to leave the checks for you to go through on your own, but n is equal to 8. Part C, 5b plus 20 equals 45. Okay, eventually we want the b by itself, but right now we have to get rid of this outlier. It's being added, so we're going to do the opposite and subtract. And we are left with 5b is equal to 45 minus 20, or 25. Now 5 is being multiplied by b, so we're going to do the opposite and divide, so that b is equal to 5. All right. Number 7, part A. 9x minus 18 is equal to 45. We want the x by itself, but first we have to get rid of this outlier. 18 is being subtracted in the problem, so we're going to do the opposite and add. Okay. 9x is equal to 45 plus 18. Okay, so let's think this through, right? 5 plus 8 is 13. We carry the 1. 1 plus 4 plus 1 is 6, so 63. Now, 9 is being multiplied by x. We're going to do the opposite and divide so that x is equal to 7. And last problem C over here, we have 7n plus 5 equals 26. Again, we want the n by itself, but we have to get rid of this outlier first. It's being added currently, so we are going to do the opposite of that and subtract. 5 minus 5 is 0. 7n is equal to 26 minus 5, or 21. 7 is being multiplied by n. We're going to do the opposite and divide so that n is equal to 3. All right? Okay, so that is how we do these, what they call two-step problems, okay? First, we get rid of our outlier, and then we divide. Okay? All right, then there's this last topic here on page 36 and the top of page 37, and it is commutative, associative, and distributive properties. Okay, commutative properties state that the order of addends or factors may change without changing the answer. Basically, 5 plus 6 is the same as 6 plus 5. 5 times 6 is the same as 6 times 5. The associative property states that the grouping of addends or factors may change without changing the answer. 2 and 3, 2 plus 3 in parentheses, and then plus 4 is the same as 2 plus 3 plus 4 that's in parentheses. Okay, it doesn't matter which one 3 associates with. Okay, adding them together is still going to get the same answer. Same thing with multiplication. The distributive property states that we can multiply each part inside the parentheses by the number on the outside of the parentheses to simplify an expression. 4 times the quantity, n plus 6, is the same as 4 times n plus 4 times 6, or 4n plus 24. Okay, I 99.9% of the time will draw these little swoops, so I know what's being multiplied by what. All right, that being said, let's do the problems here at the top of page 37. Finish showing the following properties using the variables a, b, and c. Okay, the commutative property of addition tells me that a plus b is equal to b plus a. Okay, doesn't matter what order we add them in. The commutative property of multiplication tells me that a times b is equal to b times a. Doesn't matter which order we multiply them in. The distributive property of a times the quantity b plus c is going to be equal to a times b plus a times c. That's how we distribute. This one's, I mean, commutative property is fine. Associative property is fine. Distributive property, very important. We will be using that, as you can see right here, a lot. This is a lot of what we do in algebra is the distributive property, okay? The associative property of addition tells me that if a is associated with b, a plus b, then plus c, that a plus b plus c is going to be the same thing. Now, you could have even written a plus c plus b, right? You could have even written it like this. B plus a plus c. It doesn't matter, right? It doesn't matter who is grouped together with who. They're all going to be, it's going to be the same answer when you get to the end. And same thing for this associative property of multiplication, right? So I'm going to have a times the quantity b times c. Or you could also have b times the quantity a times c, right? It doesn't matter. Any of those is correct. It's all the same, okay? All right. Now, I told you how important a distributive property is, so let's take a look at it here. I have 7 times the quantity set y plus 7, so I'm going to distribute. And I'm going to take the outside number times each part of the parentheses, okay? So because I can't add 7 plus y, right? Those aren't like terms. I can't combine them. We just practiced that a minute ago on the page before, right? We can't combine the 7 and the y. They're not like terms. So to simplify this, we distribute instead. So 7 times y is 7y. 7 times 7 is 49. So 7y plus 49 is our answer. Okay? We don't have enough information to do anymore because we don't know what y is equal to. But that's okay. Again, we're going to distribute. We're going to take 16 times a, or 16a, plus 16 times 2, which is 32. All right, over here, we have 4 times the quantity n plus 8. So we're going to take 4 times n, and we get 4n. And then we're going to take 4 times 8 and get 32. Okay, distributive property doesn't have to be hard, but it is something we will be using a lot. Okay, so we need to make sure we're practiced at it. For the last one, we have 8 times the quantity x plus 9. So we're going to take 8 times both parts, right? We can't add the x and the 9. They're not like terms. So we're going to take it, multiply this 8 by both pieces. So 8 times x is 8x, and 8 times 9 is 72. All right, there was a lot of different things we went over in this practice set. The practice problems for those, or the pre-test, is on page 33 and a little bit on page 34. So you can go ahead and do those now and meet me here for the next practice set. All right, the next practice set, number 11, starts on page 38, and it's about proportions. Now, proportions are extremely important in math, and I really want you guys to do well at these, but I do not like the way the book teaches these. So I will not be teaching it like the book says. As you can see, I don't have anything highlighted other than the word practice set, because being able to look at these, a lot of times proportions are mixed in with story problems, and so being able to decipher a story problem to solve these proportions is a lot easier and more beneficial as you go forward than these little fraction games that they have set up, which to me are kind of confusing. Okay, so I'm not actually going to be going through this. I'm going to show you how to do these in a very clear way. So let's just take a look at problem number 1 over here on page 39. They want us to use a proportion, which we will, to solve and tell us how many pounds are in 3 tons. Now, in their next book, there should be something that I usually call page 0. And let me see if I can pull it up here. So book 2 has what I call page 0. And it is right here, but right before page 1, okay? So I call it page 0. And it has a bunch of conversions and different things that, formulas and such, that are important that you would probably need to use in the book to come, right? Sometimes they don't write everything down that you need, and so I will suggest adding something to this page. But this is kind of your page to check to say, oh, I'm not sure what the proportion is for this conversion. I will go and check my page 0. Unfortunately, it doesn't have a pounds to ounces or tons to pounds conversion, so we will be taking care of that, and I will let you know of it here as we go. Okay, so problem number 1. 3 tons is how many pounds? All right, we're always going to start with what we were given, and that is 3 tons, okay? Now, if you didn't know, 1 ton is equal to 2,000 pounds, okay? So I don't know if you're a Marvel fan, right? But Tony Stark and his daughter are talking, and he says, I love you a ton. And she says, I love you 3,000, because 3,000 is more than a ton, right? That's the joke. Anyway, so this is the conversion. Now, I am starting with tons, but I want pounds. So in my proportion that I'm going to multiply, in the fraction that I'm going to make to multiply against this 3 tons, I want the unit that I want to be in the numerator. And that unit is pounds. So my 2,000 pounds is going to go up here, which tells me that my 1 ton is going to be in the denominator. Now, what this allows me to do, because technically this is a improper fraction, right? That allows me to cancel my tons, because I can cancel a unit that's in the numerator with a unit that's in the denominator, just like we were canceling with our fractions a little bit ago, right? And then what's left in the denominator is just ones, and what's left in the numerator is a 3 times 2,000 pounds. Well, that is 6,000 pounds. 6,000 pounds over 1 is just 6,000 pounds. So my answer is 6,000, okay? And this is just an easier way, in my opinion, than what they're doing here, which is probably fairly similar to the same, pretty close to the same thing, but they're like cross multiplying, dividing. It's just a lot happening in these 3 steps, where all we have to do is set up this fraction, reduce if we possibly can, and then we've been doing these types of things. In this video alone, we've done a whole bunch of these. So this is how I would prefer you would set these problems up, and this will help you going forward with all kinds of conversions, science conversions. Setting them up this way will benefit you in the long run, okay? All right, 96 hours is how many days? All right, well, we are given 96 hours, right? So we're going to set that as our improper fraction. And what are we multiplying it by? Well, how many hours are in a day, right? 1 day is equal to 24 hours, okay? So I want days. This part of my comparison, right? My conversion is going to go in the top because I want days as my answer. So 1 day is 24 hours. And that's how I set up my conversion factor. Now my hours cancel because hour over hour is 1. So I end up here with 96 times 1 day, or 96 days, divided by 1 times 24, or 24. Right? So now we have to actually divide 96 days by 24, okay? And I don't know how many of you are using calculators or not, so we will do the long division for this time, but moving past this problem, we're just going to use calculator, okay? So we have 96, and we'll probably have to have a point something there, right? So 24, how many 24s are in 96? Well, 2 24s is 48, right? 2 times 24 is 48. 48 times 2, and I'm just multiplying it by 2 because I know 2 times 8 is 16, and that's what we have here, right? 2 times 4 is 8. All right, so it's a total of 4. So I didn't need a decimal after all, okay? So the answer is 4 days. 96 hours is 4 days. All right. Now we have 30 yards and we want to change that over to feet. So we're setting up our fraction as 30 yards, and it's abbreviated YDS over 1 times what other fraction? Well, if you didn't know, for every 1 yard, there are 3 feet. Okay, so this is the conversion factor we're going to put in here. We want feet as our answer, so this part is going to go in the top. 3 feet is 1 yard. And by doing that, I can cancel. If you set up your fraction and you can't cancel out what you were given, the unit you were given, then you've got it not correct. All right, so if we can't cancel these, then we've set our conversion up incorrectly. Now, in my numerator, I have 30 times 3 feet, which is 90 feet. In my denominator, I just have ones. So the answer is 90 feet. All right. Last one, 96 inches into feet. Okay, well, we're going to start this off by setting up our 96 inches. We abbreviate that IN over 1. And what are we going to be multiplying it by? Well, if you weren't sure, 1 foot is equal to 12 inches. We want feet as our answer, so the 1 foot goes in the numerator. Therefore, the 12 inches goes in the denominator. That allows us to cancel our inches. In the numerator now, we have 96 times 1 feet, or 1 foot, which gives me 96 feet, over 1 times 12, or 12. So we're going to divide here, and we're going to have 96 divided by 12, which is 8. So we have 8 feet as our answer. All right. Now, as I said, we're not doing it exactly how the book says, but that's okay, right? This is math. There's often multiple ways to work the same problem. I'm teaching you how to set them up this way because going forward, not just in math, but also in sciences, this is the easiest way to do conversions, because eventually we're going to be doing multiple conversions. We're going to be changing things over, not just from hours to days, but maybe from hours to days to weeks to months. I don't know, it's from days to hours to minutes to seconds, right? We're doing quite longer conversions, and setting them up this way, learning how to do it this way, will benefit you in many arenas of school. All right, so that's why we're doing it this way. Going to the next section here, we have using proportions to solve percent problems. Now again, I don't like the way the book teaches this. I feel like it's pretty complicated problem. So that, that they're taking something kind of simple and making it a little bit complicated. So we are going to do it a different way. So I'm not going to be reading this. We're just going to turn the page and work through some of these problems. And the reason we're on page 40 now, the reason I'm showing you this in a slightly different way is because, remember how I said that percent problems were a lot of times part of a story problem? That's what we're talking about here. Each one of these, even though it's just a sentence, is a story problem. Even a sentence is a story problem. So if we can learn to decipher a story problem now and practice it now, as we go forward and get into more complicated story problems, we will have a jump start on that. Okay? So looking at problem number 5, the question is, what is 89% of 200? Now, I told you before that the word of in math means to multiply, right? And I'm going to use an X just as an example. But again, we're not going to use an X in our equation, right? Well, all of these words in math mean something. The word is in math means equal to. All right? And this word what tells me I don't know. And so this time I'm just going to use the variable n. Because I don't know what it is, it gets a variable. So now I'm going to rewrite this over here as a math equation. What is 89% of 200? This is what we need to do. This is the problem that we need to solve. Setting up these equations doesn't help us, okay? It doesn't help us in the long run. Being able to read a question and write it as an equation is far more beneficial. So that's what we are going to do. Now we need to change this 89% to a decimal. So we're going to move our decimal point 2 places. And so we end up with 0.89 times 200. Okay. Now remember, my 200 ends in 0. So if you are doing this long multiplication ways, I would suggest setting it up like this, where our 2 zeros come down. 2 times 9 is 18. 2 times 8 is 16 plus 1 is 17. 2 decimal places, so puts my decimal right here. So the answer is that n equals 178. All right, Let's take a look at number 6. 35 is 70% of what number? Okay, let's put in our symbols that we know. Is means equals. Of means multiply. What number? We don't know. So that is our n. Okay, so rewriting this as an equation, we get 35 equals, or 35 is 70% of what number? Or this equation. Okay, now we need to change this to a decimal. So we're going to move our decimal place 2 places. So we get 35 is equal to, I don't want this equal sign here. Draw an arrow instead. 35 is equal to 0.70 times n. All right, now, just like the problems we were solving a little bit ago, how do we get n by itself? It's being multiplied by 0.70, so we're going to do the opposite and divide. These cancel, so n is equal to 35 divided by 0.70, and that equals 50. So n is 50. All right. Problem number 7. 15 is what percent of 80? All right, so let's substitute in our mathematical things, right? Is means equals. What percent tells me I don't know. Of means multiply. So let's rewrite this. 15 is what percent of 80? Okay, piece of cake. Now, we are going to get n by itself. So we need to, it's being multiplied by 80. So we're going to do the opposite and divide. Okay, so that n is equal to what? Well, on our calculator, we take 15 and divide that by 80. And we get this decimal value, 0.1875. So 0.1875. Now, the question is asking for a percent, and this is a decimal. So we need to change this back to a percentage. When we go from a percent to a decimal, we move 2 places to the left. This time, to go from a decimal to a percent, we're going to move 2 places to the right. So this equals 18.75%. Okay? Make sure we're reading our instructions and whatnot. Now it says round to the nearest whole number or percent, so we need to round again. Round this 8 based on a 7 gives me 19. Oh my gosh. Sometimes my hands are faster than my brain. 19. Oh my word. 19%. Okay. 19% is our answer. All right. Woof. All right. Number 8. For number 8, it says, what is 150% of 70? So we don't know what the what is, so we give it a variable. The word is means equals, and the word of is multiply. So what is 150% of 70? That's what we're doing. All right, piece of cake. We don't need to do all this setting up fractions, and it's just too much. This is how we want to read it. We want to be able to read a sentence and write an equation. Boom. All right. Now, 150, we need to make a decimal so we can use it. So we're going to move our decimal place 2 places. So we end up with n is equal to 1.5 times 70. Okay. 1.5 times 70 is equal to 105. Okay. So n is equal to 105. And it makes sense that the number is bigger because it was the whole plus 50%, right? All right, number 9. For number 9, we have 31 is 45% of what number? Okay, let's stick in the things that we know. Is means equal. Of is multiply. What number? We don't know, so we put in a variable. So writing this out, 31 is 45% of what number? Boom. Let's change our percentage to a decimal. We're going to move 2 places. So we have 31 is 0.45 times n. We want n by itself. It's being multiplied by 0.45, so we're going to do the opposite and divide. Okay, so that my n is equal to 31 divided by 0.45. So 31 divided by 0.45. Okay, and it is 68.8 repeating, right? So 68.8 repeating. Now, they want to the nearest whole number. So we are rounding this 8 based on an 8, so it's going to bump it up 1. So our answer is 69. All right, last one. 15 is what percent of 20? So the is equals. What percent? We don't know, so we give it a variable. The word of means to multiply. Rewriting this as an equation. 15 is what percent of 20? All right, that's what we want to do. That's what we want to practice. That's what we want to get good at, okay? So n times is being multiplied by 20. We're going to do the opposite and divide. Divide by 20. 20 over 20 cancels, right? So we're left with n is equal to 15 divided by 20. So 15 divided by 20 is 0.75. Now the question, remember, is asking for a percent. So we need to move our decimal 2 places to the right and see that this is the same as 75%. And when we are answering with a percentage, we need to make sure we write the percent symbol down, just like we did here. All right? Okay, I know this is not like the book, but it's okay because this is a more direct way that will help you in the long term, okay? Math is the long game, and that's what we need to think about, okay? Now, if you are working on the pre-tests as your practice problems, they start on page 37 and a little bit here on page 38. Go ahead and work on those on your own, and then you can meet me back here for the next practice set. All right, practice set 12 is titled Exponents, Integers, and Coordinates. We're starting out with exponents. It says in the expression 9 to the 4th power, 9 is the base and 4 is the exponent. Okay, it's the same as saying 9 times 9 times 9 to 9. 4 9s multiplied by each other. All right, 9 squared, or 9 with a little 2, is read as 9 squared. 9 with a little 3 is read as 9 cubed. 9 to a little 4 is 9 to the 4th power, and so far. Once you get past 3, it's to the power of, or to the 4th power, to the 5th power, okay? And then it says here, multiply to find the product. So number 1, part A, is 9 to the 3rd power, or 9 times 9 times 9, right? 9 times 9 is 81. 81 times 9, okay, let's write that one out. 81 times 9. 9 times 1 is 9. 9 times 8 is 72. So 729 is our answer. Part B is 5 to the 4th power, the power of 4. So it's 5 times 5 times 5 times 5, okay? 5 times 5 is 25. 2 times. Now we have 25 times 25. 5 times 5 is 25 again. 5 times 2 is 10 plus 2 is 12. 2 times 5 is 10. Carry the 1. 2 times 2 is 4 plus 1 is 5. So the answer is 625. I'm kind of encroaching down here, but that's okay. Now, for this next part, I am going to write it out, but then I'm going to show you how to do it on your calculator so that you know. 16 squared is 16 times 16. Now, it's easy enough to type in your calculator 16 times 16, right? And get your answer as 256. But when those numbers get to be longer, it's important to be able to know how to raise something to a power without making an error. Because sometimes, like this 3 to the 5th, what if you type in 3 times 3 times 3 times 3, but you only do 4 times, or you do it 6 times, right? It can get you mixed up. Now, on this calculator that I'm using is a Casio. This X with the little empty square is the button that we're going to be using. So for 16, we press the X to the square. It makes this little like caret, and I don't know if you guys can see it or not. In a lot of calculators, this little caret is the symbol that you'll actually press, but then you put the exponent here. So in our case, our exponent is 2. We always want to close our parentheses so that when we hit equals, it is 256. Okay, now I have also a Texas Instrument here, and the Texas Instrument uses the little caret button right here, right? So if I have 16 and I press the caret and then I put a 2 in, this time I don't need parentheses, and I hit equals, I get 256. So on your Texas Instrument, this is the button you would use to raise things to a power, okay? I prefer my Casio, so that's what I'm going to be using in the videos mostly, but if I can, I will show everything on both calculators. So 16 squared was 256, all right? 3 to the 5th power, so I have 3, and then I'm going to press this button here, and I'm going to put in, I have 5, sorry, I keep moving it so that you can see, closing my parentheses, and I hit equals, I get 243. Now, again, you could do 3 times 3 times 3 times 3 times 3, right? 1, 2, 3, 4, 5, double checking you've got 5, you're going to get the same answer. But you carry a risk of making a mistake. Okay? All right. Problem number 2. It says use an exponent to write each expression. So 4 to the 8th power is 4 with a little 8. 12 cubed is 12 with a little 3. Base 9, so that's my big number. Exponent is 5, that's my little number. Now we need to count up our tens. 1, 2, 3, 4, 5, 6. So we have 10 to the 6th power. So we're multiplying 10 by itself 6 times. All right? So that's our brief review, hopefully, well, yes, of exponents. All right? Rules for combining integers. Okay? Here are the rules for combining integers. If we have two positives, a positive plus a positive, we just add them up. 6 plus 9 is 15. If we have a negative plus a negative, our answer is going to be negative, and then we just add up 6 plus 9 again to get negative 15. If we're adding a positive and a negative, or a negative and a positive, we find the difference between the two numbers, and then whichever one was a bigger number, that's the sign we keep. So 6 minus 9 is a negative 3. Negative 6 plus 9 is a positive 3 because the 9 is positive, it's bigger. Here the 9 is negative, it's bigger. I like to think of it kind of like this. If this is ground level or 0, right? We started with 6 blocks. 1, 2, 3, 4, 5, 6 blocks, right? So we went up 6, but then we came down 9. Well, there wasn't enough in our 6 stack to fill it all. So when we came down 9, we actually ended up at negative 3. Okay, that's kind of how I think about it when I'm working through these types of problems. And sometimes in my class, if kids aren't sure, that's how I describe it, right? We go up 6, but then we came down 9. And so where are we at? Well, we're at, in this case, negative 3. I guess it's kind of a Minecraft reference. I enjoy a good game here and there. Okay, but here are the rules. So let's take a look over here at the problems. Starting at the top of page 43, problem number 4A, negative 24 plus 24. Now, these are the same number with opposite signs, and so our answer is just 0, right? We know that because we've been working with canceling numbers out all day today, all this whole video. Part B, negative 18 plus 11. So the difference between these, right, is 7, right? 18, they would say, well, what is 18 minus 11? Well, 18 minus 11 is 7, and then the negative is the larger number, so the answer is going to be negative. Basically, you went down 18 blocks, then you built back up 11, but you're still underground by 7 blocks, right? Okay. 43 plus a negative 9 is basically the same as saying 43 minus 9, okay? And 43 minus 9 is 34. For problem 5, letter A, we have negative 26 plus a negative 17. Basically, we're going down 26 and then down another 17. So we're just going to add these two numbers together, and the answer is going to be a negative something, right? And that negative something is going to be a 43, right? 6 plus 7 is 13. We carry a 1, so we have 2 plus 1 plus 1, which is 4. For part B, we have negative 13 plus 23, which could also be written as 23 minus 13, right? You can always rearrange these. That's what we learned a minute ago, right, with our commutative property. It doesn't matter what order we add or subtract them in. So we can rewrite it like this. And so the answer is 10. 29 plus 18. Well, 8 plus 9, right? If you want to stack it, that's fine. 8 plus 9 is 17. 2 plus 1 is 4. 47. For number 6, we have negative 15 plus 34, or basically 34 minus 15. Okay. 34 minus 15 is 19. Right? If you need to stack it, go ahead. We have to borrow. 14 minus 5 is 9. 2 minus 1 is 1. This next one, 23 plus a negative 29, or basically 23 minus 29. Okay, we went up 23, but then we went down 29. So we passed 0 and went into the negatives by how much? The difference between these two is 6. If you are comfortable, if you have a way that you think about this and a way that you do these problems and you're great at it, you keep doing it that way. Okay, I'm just kind of giving you some options and different ways to think about it for those who are struggling with these types of problems a little bit. All right, last one, C. Negative 16 plus a negative 24. So we're going down 16 and then down 24 more. So our answer is going to be negative, and we just need to add these two things together, right? 16 plus 24 gives me 40. So negative 40. All right, switching gears a little bit for this next part, we are talking about a coordinate grid. And when we're talking about a coordinate grid, we're dealing with ordered pairs. And ordered pairs always follow this order, x, comma, y. And here we have our x-axis is always going to be horizontal. Our y-axis is always going to be vertical. All right? And our ordered pair is always moving along the x first and then the y. Always count across the x scale first and then up the y scale. The reason it's always that way is that's what makes it ordered, right? They're called ordered pairs. They're always in the same order. So when you write your coordinates, someone else can take that and understand what you mean. If we don't follow the order, then it gets too confusing, okay? So they want us to write the ordered pair for each point. Here is my point F, okay? To get there, if I'm starting at 0, 0, always starting at 0, 0, how do I get to point F? It's like it's giving me directions. I'm always going to move to the right first, and to get there, I have to move 2 points to the right. And then I'm here, and I have to go 1, 2, 3 points up. And so those are my coordinates, 2, 3. For point J is here. How do I get there? What are the directions from 0, 0 to point J? Well, I have to move 1, 2, 3, 4, 5 points along the X, and then 1 point along the Y. Now here they want us to insert these points. And the first point we're going to insert, oh no, they want us to write the point that is at the coordinates. And our first coordinate is at 6, 5. So I'm starting at 0, 0. And I'm going to go 1, 2, 3, 4, 5, 6 to the right. And then 1, 2, 3, 4, 5 points up. And I land at letter E. For part B here, it wants to know what point is at the coordinate 3, 3. Starting at 0, 0, I'm going to the right 3, 1, 2, 3. And then I'm going up 3, 1, 2, 3. And that's letter G. Now it wants us to plot these points on the grid. They want us to plot point K at 0, 4. So I'm starting off at 0, 0, and my coordinate tells me to go 0, which means I don't move to the right at all this time. But I'm still going up 4 points. 1, 2, 3, 4. So I'm going to put a dot there, and I'm going to label it K. For part B, we want to put letter L at 2, 1. So I'm starting at 0, 0. I'm going to the right 2. I'm going up 1, and I'm putting a dot, and I'm labeling it letter L. All right, so coordinates, got to remember, always X, Y. Always right, up. For now, the coordinate plane goes a lot of different directions, but for you guys to get started, we're just going to be starting in quadrant 1, this quadrant here. Okay, if you are doing the practice test as your homework or practice problems, that's here on page 41. Go ahead and finish those on your own. And meet me back here for the final practice set. So practice set, primes and factors. It says, using factor trees to find prime factors of a number. Now, factor trees are... okay, does the other thing, or they're fine, but they take up a lot of space. On the next page, we're going to learn a slightly different way, but let's take a look at the factor tree for now. It says a number is a prime if its only factors are 1 and itself. The number is a composite if it has at least one other factor besides 1 and itself. 0 and 1 are neither prime nor composites. Okay? Every composite number can be written as a product of its prime factors. And they do that here with this 72, okay? They break 72 into all of its parts, and then the prime numbers that are left are its prime factors. All right, so we're making branches, we're making a tree, right? Often there are several ways to make a factor tree. Okay, the final answer, though, no matter which way you do it, will be the same. Because, of course, there are many ways to get, in this case, to 100, right? So we're starting at 100. There are many ways to get to 100. This number times this number, this number times this number, right? One of the easiest ways to get to 100 maybe is 10 times 10. Maybe you thought, well, 2 times 50 is 100. Yeah. It is. 25 times 4 is 100. So there's many different ways to make up your factor tree. So I am obviously only going to do it one way because I'm not going to do the problem multiple times. If you wanted to do it a different way, then do it a different way. And meet me at the end and let's compare our answers, okay? So I'm going to break my 100 into 10 times 10. Now 10 is 2 times 5. Both of these are prime numbers. And this 10, again, is 2 times 5. And that's a prime. Those are prime numbers, okay? So the list of the factors is 2. We want to write them in numerical order. So 2 times 2 times 5 times 5. Okay, now again, you could have gone any way. This is just the way that I chose to go. 48. Okay. 48 is 24 times 2, among many other things, of course. Now 2 is a prime factor, so that's the end of that one. 24 can be 8 times 3. It can be 4 times 6. It can be 2 times 12, right? I mean, there's lots of different ways to get to 24. I'm going to choose 8 times 3. Now 3 is a prime factor, so that one's going to stop there. 8 is 4 times 2, 2 being a prime, and 4 is 2 times 2, which are both primes. So I have 1, 2, 3, 4 2s. So 2 times 2 times 2 times 2 times 3, don't forget that 3, are the prime factors of 48. Problem 55 is, right off the bat, I'm thinking of 5 and 11. Now, both of these are prime factors, so we're really just at the end here. 5 times 11 is how we get to 55. It's the only way. Okay? That one, there is no other way. So this is our factor tree, how to use the factor tree, how to make a factor tree. Let's turn the page. At the top of page 46, it says upside down short division. Now, this is the way that I typically will do my factoring, which is down here. But first, they're going to show you the upside down division part. It says short division is a mental form of division that works well with one-digit divisors. And I've kind of been doing this already throughout this whole book, right? I've kind of been doing a little bit of short division, sometimes long, sometimes short. And it says we may do short division upside down, writing the answer underneath instead of above. And so that's what this looks like, okay? This is going to lead us into prime factoring in a upside down short division, however you want to call it, way. And that's the way I typically do my factoring. But let's take a look at the short division first. Do short division, it says. So we have 305 divided by 5. 5 does not go into 3, but it does go into 30, right? 5 goes into 36 times, and there's going to be no remainder. And 5 goes into 5 one time. So the answer is just 61. For 916 divided by 4, this one's going to be a little bit different. We're actually going to be able to use our short division, right? 4 goes into 9 2 times. 4 times 2 is 8, so there's 1 left over. And we just kind of tuck it in right there. So now this becomes, instead of just being a 1 in that space, it's an 11 that's in that space. So then how many 4s are in 11, right? That's what we have to think about. And there's 2 4s in 11. 4 times 2 is 8. So that means that there's 3 remaining. And so we stick the 3 over here. Now we have, instead of just a 6, we have a 36. How many 4s are in 36? 9. Okay, so this is how we do short division. Okay, we're skipping all of the writing it out, subtracting. We're just kind of subtracting in our head and adding our remainder to each of the numbers, just like they have here. Let's take a look at part C. 744 divided by 3. Well, how many 3s are in 7? There's 2, right? That's 6, which tells me there's 1 left over. So I stick it here with this 4, it becomes a 14. How many 3s are in 14? Well, there's 4 because that's 12, right? Which tells me there's 2 left over. So now this becomes a 24. And how many 3s are in 24? There are 8. So the answer is 248. All right. 705 divided by 5. 5, how many 5s are in 7? There's only 1, but there's a remainder of 2. How many 5s are in 20? There's 4. How many 5s are, and that's a full thing. There's no remainder, right? 5 and 5 is 1. So 141. Now, the short division upside down is kind of interesting, but it's really just leading into this factoring. But let's go ahead and work through these. 267 divided by 3. There are no 3s in 2, right? But how many 3s are in 26? Well, there's 8 of them because that's 24. So that leaves 2 behind. And then how many 3s are in 27? 9. Okay, so the answer is 89. 536 divided by 2. How many 2s are in 5? Well, there are 2 of them. right? And there's a remainder of 1. So now I have 13 in the middle. How many 2's are in 13? There are 6, right? Because 2 times 6 is 12, which tells me that I'm still having 1 remainder. So the 6 here becomes a 16. And how many 2's are in 16? 8. All right, I know I'm going kind of fast. This video is a bit long. As we go forward into the next books, these videos won't be as long, and I'll be able to slow down a little bit. But we're almost done with this book altogether. So we're going to get through these last couple problems. 175 divided by 7. Now, there are 0 7s and 1s, but how many 7s are in 17? There's 2, right? 2 times 7 is 14, so that's 3 remaining. Okay. So now we have 35 here. How many 7s are in 35? Well, there are 5, right? So our answer is 25. Last one. 485 divided by 5. There's no 5s in 4, but how many 5s are in 48? 9. 5 times 9 is 45, so there's 3 remaining. How many 5s are in 35? 7. Now, they do this setup to set you up for this factoring. This, as I said before, is the way that I typically factor my primes, okay? And so when we do these going forward, I will be using this method instead of the tree, because the tree, in my opinion, gets a little messy, all right? So I will be doing this way. So how we set this up is we're going to put our 96 inside the bracket. And I don't really make a division one. It just looks like this. And then I want to say, what is the smallest prime to go into 96? Now remember, primes are 2, 3, 5, 7, 11, 13, and ... They go on and on forever, amen. We're trying to get to the smallest ones, okay? So 96 is an even number, so 2 definitely goes into an even number. So how many 2's are in 96? Okay, well, how many 2's are in 9? There are 4, right? 4 times 2 is 8, so there's a remainder of 1. And how many 2's are in 16? There are 8. And then I put another box. So I'm down to 48 now. 48 is still an even number, so again, I know my prime number 2 goes into that. But how many times? Well, how many 2's are in 4? There's 2. How many 2's are in 8? There's 4 of those, and I put another box. 24 is also an even number, right? So I know my 2 is going to go into that, and it goes into it 12 times, and it goes in a box. 12 is even, so I know 2 goes into that, and it goes into that 6 times. 6 is even, so I know 2 goes into that, and it goes into it 3 times. This is how we know we're at the end, is because 3 is also a prime number. And so we're done. When your number down here is a prime, you've finished. And so the prime factors of 96 are 2 times 2 times 2 times 2 times 2 times 3. And that's 5 2's. I believe 1, 2, 3, 4, 5. Yep, 1, 2, 3, 4, 5 2's and a 3. Okay, I prefer this method. I feel like it's a little bit cleaner and easier to see because all of your prime factors are on the outside. All right, so let's take a look at the next one. 125. Now, I told you to start with the smallest one, but sometimes when we have a 5 or a 0 at the end, it's just our nature to burst out with, oh, a 5 goes into that, right? So we'll just do the 5. So how many 5's are in 125? Well, how many 5's are in 12? There's 2 of them, right? But there's also a remainder of 2. And so then how many 5's are in 25? There's 5. Now, a prime factor of 25 is 5, and it goes in 5 times. My final answer here is a prime, so I'm done. That's the end. Okay, there's no further I can go. So it's 5 times 5 times 5. All right, last one over here. 294. It is an even number, so we're going to start with 2. Okay, how many 2's are in 294? Well, there's 1, 2, and 2. there's 4 2s and 9, and that has us carrying our 1 remainder. And there are 7 2s and 14. Okay. Now this is not an even number, so we can't use 2 again. So let's try 3, because right off the bat, just looking at it, it's pretty unclear what is actually going to work in here. So let's try 3. How many 3s are in 14? Well, there are 4, right? And that's 12. So there's 2 remaining. How many 3s are in 27? There are 9. Okay. Now, if you know your multiplication tables really well, you'll know that 7 times 7 is 49. And 7s are both prime numbers, or 7 is a prime number. And so we are at our end. So the factors of 294 are 2 times 3 times 7 times 7. If you don't recognize this right away, you're going to have to do the steps. You know, 2 is not going to go into it. So then you can check 3, and you can check 5, and you can check 7, and so on until you get there if you didn't recognize it right off the bat. Okay? But those are the prime factors there. All right. Now, at the top of page 47 are some more problems. I feel like we've done a lot, though, so I'm going to leave those for you to do on your own. And then also on bottom of page 43 and page 44 are some more problems for you to practice. Now, in this particular book, and it's only going to be in this particular book, lesson 14 and lesson 15 are what they call a self-check. Okay, and basically it's review, more practice problems, more review of all of the things that we've done thus far. Okay, and then here you'll see that lesson 16 is taking your test, which again was in the middle of the book. And then lesson 17 is just a fun puzzle, and there's a bunch of activity puzzles at the end. Okay, feel free to do them or not, however you want to handle your school day. But that's it then for book 701 in this curriculum. All right, when we come back and see each other again, we'll be starting in book 702 that has a completely different layout from this, and it's very manageable, and it's going to be great. So, as always, if you have any questions, do not hesitate to contact me. Otherwise, until next time.